In previous module, we have seen that if H is subgroup of G and N is normal subgroup of G, then Hn is subgroup of G. Now in this module, we shall state and prove second isomorphism theorem. Let's state the theorem. Let H be a subgroup of the group G and let N be a normal subgroup of G. As we know that the condition of normality is for every x belonging to G, x H x inverse xn x inverse belongs to capital N. Then we say that N is the normal subgroup of G. Then Hn over N is isomorphic to H over H intersection N. Now we prove the theorem. Let Y from G to G over N be the canonical homomorphism and let H be a subgroup of G. Then image of H under Y is a subgroup of G over N. हम इस थ्योरम को प्रूव कर चुके हैं. If phi is a homomorphism from G to G prime, then the homomorphism would preserve the subgroups. अगर आपके पास H subgroup है G का, तो image of H under phi is the subgroup of G prime. We have already seen this. So by using this result, we can say that YH is a subgroup of G over N. Now the action of Y on just the elements of H called Y restricted to H provides us with a homomorphism mapping H onto YH. YH is the image of H under Y and Y is from G to G over N. This is the Y is the canonical homomorphism. And the kernel of this restriction is clearly the set of elements of N that are also in H. That is the intersection of H and N. तो यहाँ पर आप देख सकते हैं, अब हम फर्स्ट आइसोमॉर्फिज्म थ्योरम यूज़ करने जा रहे हैं और कर्नल हमारे पास H इंटरसेक्शन N के इक्वल है कर्नल ऑफ Y और Y is a homomorphism from G to G over N. So by first isomorphism theorem, there is an isomorphism mu1 given by H over H intersection N to YH, image of H under Y. और हम by first isomorphism theorem, H over H intersection N is isomorphic to YH, image of H under Y. On the other hand, Y restricted to Hn also provides a homomorphism mapping Hn onto YH because Yn is the identity element capital N of G over N. और जैसा कि आपको मालूम है Y हमारे पास होमोमॉर्फिज्म है फ्रॉम G to G over N, कैनोनिकल होमोमॉर्फिज्म है. तो अगर कोई एलिमेंट N को बिलोंग कर रहा होगा तो हमारे पास वो G over N के अंदर हमारे पास तमाम लेफ्ट कोसेट्स हैं और G over N क्योंकि N नॉर्मल सब ग्रुप है तो G over N कोशेंट ग्रुप है और कोशेंट ग्रुप का आइडेंटिटी एलिमेंट कैपिटल N है. If an element belongs to capital N, it would maps on the identity element of G over N, that is capital N. The kernel of Y restricted to Hn is n. Now we shall apply the first isomorphism theorem, and by first isomorphism theorem the quotient Hn over n is isomorphic to YH. तो इसे पिछली स्लाइड पे आपने देखा कि हमारे पास जो आइसोमॉर्फिज्म है H over H intersection n is isomorphic to YH, image of H under Y, and on this slide we have mu2 isomorphism. Hn over n is isomorphic to YH. So these two are the isomorphic, Hn over n and H over H intersection n. Because Hn over n and H over H intersection n are both isomorphic to YH, they are isomorphic to each other. Indeed, phi from Hn over n to H over H intersection n, where phi is defined, is given by mu1 inverse mu2, will be an isomorphism. यहाँ पे आप देख सकते हैं कि mu1 inverse mu2 composition of two homomorphisms को represent कर रहा है, और mu2 हमारे पास homomorphism है from Hn over n to YH, और फिर पहले mu2 अप्लाई होगी because composition is operated from right to left, और देन mu1 इनवर्स हमारे पास अप्लाई होगी और mu1 इनवर्स YH को H ओवर H इंटरसेक्शन n पे मैप कर देगा. तो इस तरह से हमारे पास जो फाई है, दिस इज अ होमोमॉर्फिज्म Hn ओवर n टू H ओवर H इंटरसेक्शन n, और ये आइसोमॉर्फिज्म है. More explicitly, we can write phi Hn equal to mu1 inverse mu2 Hn n, capital N. और यहाँ पर आप देख सकते हैं कि जो हमारे पास एलिमेंट है Hn वो इस क्वोशिएंट ग्रुप का एलिमेंट है, और ये हमने जो स्मॉल Hn है वो कैपिटल Hn से पिक किया है एलिमेंट, और हमने कोसेट की फॉर्म में, क्योंकि ये क्वोशिएंट ग्रुप है इसलिए कोसेट की फॉर्म में इसको लिखा है, और mu1 इनवर्स mu2 Hn n पे अप्लाई होगा, and when mu2 Hn n gives us Hn, and mu1 inverse Hn equal to H intersection n, which is the coset in Hn over which is the coset in let's move to next slide, which is the coset, because we are considering mu1 inverse, and coset in H over H intersection n is H intersection n. Hence we established the theorem.